Okay, so I think we are all set. So let's start. So can everybody hear me? Okay, during the webinar, if you have any question or comment, please type in your question at Q&A or comment at chat in English, please. And no recording, please. So hello, everyone. We have something special down here at Zoom webinar this evening in Japan, morning in Germany. That is Saitama City Foundation for Business Creation, SFBC, and State of Bavaria, Japan Office Joint Project Webinar 4. This is the final one. Thank you for joining us today. Please let me introduce myself. I'm Kato from SFBC, and then I would like to take this opportunity to thank you all for your cooperation, and special thanks to State of Bavaria, Japan Office. First, we're going to have an opening remarks from Chief Representative of State of Bavaria, Japan Office, Dr. Christian Geltinger. Dr. Geltinger, please start.
Yes, thank you very much, Pato-san. Good afternoon to everyone here in Japan. Good morning, everyone back in Germany, in Bavaria, my home. It is a pleasure to kick off the 4th edition of this seminar series, which is a joint effort by our partners from Saitama. And I have to say a very close partner and friendly partner, not only to our office here in Tokyo, which is on the picture behind me next to Tokyo Tower, but also to all of Bavaria. You may know from the previous editions and previous projects that Saitama initiated with Bavarian partners that they are very active in the various of fields, starting from robotics, mechatronics, up to medical technologies, and will move into other areas as well, like Industry 4.0, IoT, and others to come. So this is a very interesting journey that we undertake together. And also the seminar series is kind of a small journey. We started, if you remember, last year with my presentation here in Tokyo, talking about the German Industry 4.0 current situation, especially for SMEs. Then the journey went on to Munich, the capital city of Bavaria, where we had a lecture about cybersecurity issues, very, very important and even of growing importance for all our industries. Then we went to the east of Bavaria, to Regensburg, where we had an input from Professor Dowling, chairman of the Münchner Kreis, a very influential body for politicians and decision makers on the digitalization and the new business models in Corona times. And now we conclude the circle, so to speak. We move to the west of Bavaria, go to Augsburg, a city that is very well connected to Japan, very historically as well. Was one of the first German cities to start a sister partnership with a Japanese city. And that reaches back to times where we had very famous production in engine technologies. So it goes back to the diesel technology. And here in Japan, it was no other than Mr. Yama himself who actually picked this technology up and initiated this sister partnership now with Nagahama and Amagasaki. And if you ever have a chance to visit the German embassy here in Tokyo, don't miss out the opportunity to visit the famous garden, Japanese garden of the embassy, where you can see a very famous bell donated by the Yama family to this German-Japanese friendship. And let me just share one slide with you that gives you, I hope it can be visible, the QR codes at the bottom, where you can follow the previous sessions of the seminars that I just mentioned. And our office here in Tokyo is, of course, your stepping point, your navigation assistant towards Europe, towards market entry into the European market, into the German market, which is by far the most important market in Europe, and of course our Bavarian home base. So please use our facility here, our office here, and use especially the partner in Saitama itself, which is very proactive and very professional. So thanks a lot to Saitama City Foundation for Business Creation for all your efforts so far. And with that, I look very much forward to the presentation from the University of Augsburg on artificial intelligence in manufacturing. And yeah, I can't be more excited about this. Thank you very much again for attending, and see you soon here in Tokyo.
Okay, thank you very much, Dr. Geltinger. So let's start the webinar now. AI production network from basic research to industrial applications. Joint presentation by Professor Dr. Malte A. Peter, Vice President, Innovation, Transfer and Alliances, University of Augsburg, and Professor Dr. Marcus Sause, Mechanical Engineering, Institute of Material Resources Management, University of Augsburg. Would you please start the presentation? Thank you.
Yes. Can you see my presentation?
Yes, we can see that.
Perfect. Well, thank you very much. Thank you very much for the invitation in particular, and for the opportunity to present our artificial intelligence production network, which is a very recent, if not the most recent, major project of the University of Augsburg. And so for about the first third or half of the time, I'll be introducing the general ideas and sort of where we're at from a sort of general point of view, show you how it fits into the Augsburg region, why we think it's a really great project for the university as well as the region. And then in the second part, Professor Sause, who is responsible for the whole operation, will talk more about the details. And just let me mention that seeing Tokyo skyline in the background of Dr. Geltinger's screen, I was in Tokyo about 1.5 years ago, and I think it's a real pity that we can't come to visit you in Japan and give the presentation in person. So we have to make do with this, but I hope you enjoy the presentation anyway. So let me start with a brief introduction of the University of Augsburg and the city of Augsburg, just to explain why we think this is a really great project, and why this fits very well into the development of the city and the region. So just some facts and figures of the city of Augsburg, and with this I invite you to all come to Augsburg and have a look yourself. Augsburg is the capital of Swabia, which is the southwestern region of Bavaria, and I hope you can see this dot on the map here in the south of Germany. That's where Augsburg is located, about 60 kilometers west of Munich. Augsburg has about 300,000 inhabitants, and what is quite remarkable, it's the second oldest city in Germany. It was founded more than 2,000 years ago. And you can see a few impressions here. And as Dr. Geltinger has already mentioned, it's got a long history in production technology, and we'll come to a few of these during the talk. Now, the University of Augsburg is a rather young university. It was founded in 1970 as the 6th university in the state of Bavaria. There's 10 universities today. And it's set up on a campus which used to be an old manufacturing site and airfield from Messerschmitt, you may have heard, the plane company. And so it's a rather big piece of land, which before the university was established was just all fields and green basically at the time. And now, of course, there are quite a few buildings, but there's also still quite a bit of space, and the university is expanding, and I'll explain that. But just a few more facts and figures. We have about 225 professors at the moment, around about 1,000 academic staff members, and about 800 administrative staff members across 8 faculties. And we offer about a little more than 80 degree programs, about half bachelor's programs and about half master's programs. And at any one time, we have around about 20,000 students. So it's sort of a mid-sized university for German standards. We have the whole range of subjects, really. We've set up within these 8 faculties, and the two faculties I want to talk about most today, or at least relate to most today, are these two: the Faculty of Mathematics, Natural Sciences, and Materials Engineering, and the Faculty of Applied Computer Sciences, because this AI production network that we've been setting up is particularly combining the expertise of these faculties, and is a joint undertaking. So to explain to you how this all came about and why we are establishing this network today, I want to explain some of the history of what we call the technology campus. So as I explained, the University of Augsburg was set up on this big piece of land just south of the city center. And towards the southern end, there used to be still quite a bit of green space. And now within the university, over the last 10 years, a number of things developed. Starting in about 2009, I could go back a little further, but just for reasons of time, not to go back too far, just sort of to show you the range of the last 10 years. In 2009, the university set up the Institute of Materials Resource Management, which was the starting of engineering at the University of Augsburg. So this is really where the engineering happens, or the engineering professors are located. And at the same time, a while back, the Faculty of Applied Computer Science was founded, and in 2009, so in the same year, they got their own large building, which you can actually see on the map. It's this building here. That was sort of developments within the university, and also in 2009, the Fraunhofer Institute was set up. You probably well know that the Fraunhofer Society has many institutes, typically having very close links to industry and doing applied research jointly with industry and for industry. So this was set up at the same time. Now, basically, this accelerated a lot of further development, and one very important milestone was in 2013, when the Fraunhofer Institute for Casting, Composite, and Processing Technology was opened, just slightly further south, around here. And also the German Aerospace Center set up an institute, the Center for Lightweight Production Technology. And these two institutes, they are our main partners in the artificial intelligence production network that I'm presenting today. So they were set up in Augsburg in 2013, and you can sort of see more of the history, not just by the buildings being set up, but also by major projects. There was MyCarbon starting in 2012, a leading edge cluster funded by the German government. Professor Sause will talk a bit more about that later. And what was also set up, very important to us, even further south, this building here, was what we call the Technology Center of Augsburg, which is basically a big co-working space and also lab space for companies, also the university, to rent space, to set up little projects, start up businesses, rent space. There's actually, at the moment, another institute of the German Aerospace Center, which has been founded, where they don't have a building just yet, but they're also operating from this co-working space at the Technology Center Augsburg. This is this institute here, the German Aerospace DLR Institute of Testing and Simulation of Gas Turbines. And there's a new building being set up at the moment. At the same time, there's also another major project, the Campus Carbon. Again, Professor Sause will talk about that later. And quite important to the development of the university is this project here. It's called WIR, basically Knowledge Transfer Region Augsburg, which is also funded by the German federal government. It's within the within the excellence initiative of the German federal government. And what these kind of projects are supposed to do, they're supposed to establish structure and governance within the university for transfer of knowledge. And this project has been very important in basically kickstarting that and furthering the development of this transfer of knowledge branch at the university. And you can see it's still running. So it's been a big push for the university in this direction. And there's also two more things. Just last year, the Fraunhofer Institute for Casting, Composite and Processing Technology, which was set up in 2013, they got another building just down here, and also the Institute of Materials Resource Management, our engineering school, if you like, which was founded way back here, also moved into their own building, which is just beside it. So it's all this huge extension of the campus to the south, all to do with technology. And so what with all this pre-work, if you like, we have now initiated this AI production network. So just to a bit more focus on what are very strong fields of competence at the University of Augsburg, which feed now into this AI production network. There's a strong focus on materials, material design, material simulation, material characterization. Really, many different researchers working on, well, broadly speaking, things having to do with materials. Also, there's a focus on self-adaptive process technology which has developed very strongly over the last many years, and also, of course, artificial intelligence in many sorts have been researched on at the university. Just to mention one thing, there's a researcher, a female professor from the University of Augsburg in computer science, who's working in artificial intelligence. Just this year was awarded the Leibniz Prize, which is the most prestigious prize handed out by the German Research Foundation for research and scientists in Germany. So she's been working at the University of Augsburg for many years, and she was awarded this very prestigious prize this year. There's also a focus on self-organizing systems, a focus on robotics and automation. You can see here a KUKA industrial robot. KUKA is one of the big companies in Augsburg, so there's strong links with KUKA. There's and also more from a slightly more theoretical point of view. There's quite a number of groups who do a lot of numerical methods, in particular for process technology and also for characterization, simulation of materials. So all of these things together, we've are sort of feeding into the AI production network. And so basically, the University of Augsburg, from the University of Augsburg, of course, where our main thing is basic research but also very strongly with an applied perspective. But this AI production network is not just about basic research in these areas, but there's basically really the main point is bringing these technologies, this knowledge, the skills into industry and to work closely with industry. And there has been very strong links with industry directly. The University of Augsburg has been having directly, But we thought to set this up on a very large scale, we've joined forces with our partners who are have a strong focus directly on applied research, the German Aerospace Center DLR and this Fraunhofer Institute that I've been mentioning. And with these, we want to feed into industrial development, where again there's a strong history with these clusters, the cluster Mechatronik and Automation, and this My Carbon cluster, which, as I said, Professor Sause will talk about later. And the things we want to work on mainly, because there's this strong background, is lightweight materials, digitization of the value chain, and in particular, of course, use of artificial intelligence all the way along the value chain. So not just in a very focused region somewhere, I don't know, design of material or something, but really the whole through the whole process, we want to integrate artificial intelligence. So just to give you a brief glimpse of partners, you can see we've been industry partners of the University of Augsburg. We've been collaborating with in the past. There's very big corporations. There's small businesses, small and medium enterprises. Just to give you a glimpse, and also to make the point that we're really not focusing on a particular industry, but we want to this whole operation is to be set up to really offer things to a whole range of businesses. And we've been very fortunate that we've had this idea, and of course, to realize such ideas, you need funding. And we've been very, very fortunate. We're very grateful for funding that has been or is being handed out, I should say, which has recently started. On the one hand, from the Bavarian State Ministry for Economy, Regional Development and Energy. They have set aside 46 million euros, basically split up into 30 million euros for collaborative research projects with industry, as well as 8 million euros each for these applied research institutions from Fraunhofer and DLR, the German Aerospace Center. And at the same time, the Bavarian State Ministry for Science and Art, this is basically where, for instance, the university is being administrated, also is giving 46 million euros to set up this production network, 34 of which go to the University of Augsburg directly. And there's also another partner, the Augsburg University of Applied Sciences, who are being given 12 million euros from these 46. So altogether, the Free State of Bavaria is funding this operation with 92 million euros. And we're very, very grateful for this funding, really enabling us to realize these plans. So just to speak a bit more about what we're actually wanting to do and how this came about, what are the motivation and goals? So there was a study called KIPRO. KI, by the way, is AI in German, Künstliche Intelligenz, artificial intelligence. And that basically focused on companies in the Augsburg region, basically asking the question, what is the potential of AI for these companies? And it became quite clear that there is a lot of potential for AI for material appropriate production. So really, production technology could be enhanced, and the potential should really be leveraged. But the companies also said, well, one of the main problems for using artificial intelligence is that, of course, this is all based on data, and there is a very big lack of good data on the one hand. Also, a problem is standardized interfaces, and very, very big problem is the lack of in-house experts in the field of AI. So even if the company agreed that or realized that there's a big potential and they want to make use of this, they don't really have any experts who can judge what is best to do or even to realize it. And with this, it became quite clear that there are no education or training programs for company members. So even if the company said, okay, we don't have much knowledge about this, we're happy to invest in knowledge, to school, if you like, to educate our employees, there was hardly any offerings. And so so basically, two essential. We learned from this is that when we came about with this idea of the AI production network, it was really based on two essential aspects. Well, first of all, is we need to do research and development on the technologies and the concepts on the one hand, but also if we do this here at the university or Fraunhofer, DLR, and so on. It needs to make its way into the company. There's also a big need for knowledge and skills transfer into industry, in particular also skills and these educational aspects. So this is basically the background idea of this AI production network. And just a bit about the structure and the vision. So just to give you one example of how we want to implement this and where this is supposed to be used. So for there will be a big focus on a highly modular, material optimized production. So assume you're interested in some design of a workpiece. So there's a workpiece here. This is the design you want to produce. So there's a number of different materials that you can use to realize this design, and so what we want to start out with is there's artificial intelligence can be used to make this choice in design and materials. But now, for instance, if you want to produce this workpiece from these materials, so there might be different steps you have to take: additive manufacturing, subtractive manufacturing. Joining of parts, and you get again within these production steps, you can use artificial intelligence for optimization and for control. Moreover, so you might get this thing out here, which may be technically optimal, which of course is good. On the other hand, you might not be entirely interested in this workpiece being technically optimal. You might want to have the same thing, but with different materials, such that it's economically optimal. Which again, now going back, means you have to adjust the production process. Or if you want something that is resource optimal, again, you might have to adapt the production process. Well, the question is again, how do you do this in the best way? Again, AI is supposed to come in to help you here. And of course, in this planning, we want to use and make use of artificial intelligence as well. And so basically, the artificial intelligence idea is at the very center of everything. And there's a big exchange of data in all steps. And I just want to basically sort of roughly show you which things need to be linked. There's a product design, everything about the materials, these different manufacturing processes, including inline quality assurance, also something that's very important. Of course, data is a big problem. I've touched that already. And of course, you want to be able to, within the production process, to adjust your optimization targets. This is sort of the overall idea. And just to give you a picture of what we're setting up, we're setting up a facility again, just here on the campus. And you see the scale here from this truck driving in with these modular production sites that are linked, and where different production processes can happen. And there's also co-working spaces are being planned where companies can come in, bring in their own equipment and link it up with equipment that's already there. And what's I think the most important part here is that companies can come in, send employees to have a look and to try what these artificial intelligence enhanced processing technologies can do for them for their production sites. So it's really about enhancing, say, standard production production chains, and really being able to get people in and to show them what it can do for them. So with this, I'd like to pass over to Professor Sause, who will start now on the technical and scientific focus. Thank you.
So, good afternoon. Hello and welcome from my side. Well, we've just heard the Vice President, Professor Peter. So the whole concept of the AI production network is just about to start. So I will give you a brief insight in the technical and scientific goals that we have, and also provide you an insight on the roadmap later on. But in between, I will rather take the chance to familiarize you a little bit more with the historical measures that we've taken to fasten the collaboration between academia and industry. So starting with, we've set up 6 fields that we wanted to take a closer look at in the framework of this AI production network. So the first one is the generative design methods and material development, meaning all methods centered around additively manufactured parts, mostly independent of the material type. So we will talk about polymers as well as fiber-reinforced polymers, about metal ceramics and also construction materials. But we're also taking the advantage of AI being used for the development of materials, for improved processing, for resource efficiency, and also for recycling purposes. Another big part will be digital twins. That is something that everyone's talking about, yet no one is really clear about what is a digital twin exactly. So we're taking the broad approach and think about it more generalized. So we talk about the digital twins for the product, like the car, as you see in front of you, about the digital twin of the material itself, about the process, and also about the whole network. So we really want to have that data be available on every level throughout the production process, and therefore allow that exchange of data as just previously sketched. Nevertheless, at least in Germany, we do have a big concern in the public about the potential loss of workspace due to automation, but in particular related to the field of AI. So we wanted to turn it around and also increase the enthusiasm about technology a bit more by providing human-centered production technologies. So we're really thinking about the workplaces of the future, and we try to integrate the needs of the humans in those production settings so that they fit well alongside with AI assistance systems, for instance. So the other 3 fields are self-organizing process route planning. So with that facility in mind that was just sketched, we'll of course need some supervisual AI system that will take care about the process route planning if we really want to adapt our process due to the needs of different materials or different optimization targets. And for every fabrication process and step, we want to look more closely into self-learning systems, meaning that sensor systems will be integrated, are monitoring what's going to happen. And then we have typically AI-driven systems that then will adapt the process parameters so that the optimization targets are actually reached. And that would be a typical setting for a closed-loop production where we actively fed in quality control results into the production step. Last but not least, we will also have a closer look into resilience, in this case with a focus on the value networks and the supply chains. So you have that map of the campus in front of you visually now. So there's different settings, and we will also be able to not only set up the one facility, but also want to link that with the other research facilities and the production capacities that are located there. So really thinking about this network also in a physical way, which is a good piece to demonstrate that also to the companies that they can operate such a system across multiple locations. So therefore, that's the 6 big fields that we want to target in the future. So as just stated, the whole thing has just started by the 1st of January, so there's not so many results I can show you at the moment. So therefore, I rather want to go back a couple of more years and would like to explain a bit better why we set up that collaboration that way, so that it may become a blueprint setting for something to realize on your own. So I'm going to talk about selected examples for industrial collaboration as we laid out in the past. So we were mentioning this cluster MyCarbon. It was a leading edge cluster been funded by the German government. And as a target, we had several key sectors in that area. So we have a whole lot of companies, been experts and world market leaders in developing machinery in all sorts of engineering. We have, of course, a strong automotive branch in the southern region of Germany, and we have aerospace, like in this case, Airbus helicopters, which have their main facility just north of Augsburg. Now, we are talking about that typically across different industry platforms, yet there is common goals, and in this case, this cluster MyCarbon was donated to carbon composites. So we had the goals at that time, 10 years ago, that we wanted to enable high volume production capacities for that material. We also wanted to internationally establish SME suppliers for that carbon composite material. And now we also wanted to anchor the use of that material in the mindset of the public. So, of course, everyone knows about metals and everyone has some association with what a metal is. But if we talk about a carbon composite, probably some know very well, but for others, it is an entirely new material. So what we did is we went into the schools along all of the educations to the kids and also to the broad public, trying to get their attention for that material and also to, again, develop that mindset, been positive about the use and exploitation of such new materials. So again, it was about the first time, I think, that we linked the use of technological developments alongside with supplementary aspects like an inclusion of the broader public in our technological aims. So nevertheless, there were some very detailed technological aims here. So you can see the map of the southern part of Germany on the left, and all of the blue dots are the partners from that network at that time. So it was about 103 partners, which turned into 33 research and development projects, and among that been 53 beneficiaries. In the center, you can see the composition. So there were just roughly 1/3 large enterprises. The majority of the participants was small and medium enterprises, and the rest was composed of the research and development facilities like the universities, but also Fraunhofer and the German Aerospace Center, and also others like governmental parts. And we had some clear vision about what to achieve with carbon composites at that time. So we wanted to be fast, so short cycle time, less than 1 minute per production part. We wanted to reduce the process costs a lot, by 90% in total. We wanted to increase efficiency a lot. We wanted to decrease the waste that has been produced. And of course, we wanted to increase the recycling rate or the use of recycled material and end up with a positive carbon footprint. So again, this was 10 years ago, so probably now this sounds a bit old-fashioned already, but this was what happened at that time. So there was a whole lot of projects initiated with a total project sum of 80 million euros, been split up into 3 main categories: production systems, efficiency and sustainability, and design and engineering. And again, what I was just mentioning, knowledge. So alongside projects that dealt with the inclusion of the public, but also already a bit about digitization at that time. So there was a whole lot of things achieved, and time will not be enough to present all of the results. So I will just select 2 exemplary projects and their results to get you an idea of what has been achieved at that time. So here is the so-called project MySkelet. So that's German for skeleton. But it's not dealing with bones, it's dealing with a redesign of that automotive structure that you see on the right. So this is obviously a BMW car, and the aim was to take the part, which is already a carbon composite material in the established design, but to redesign it to be more resilient and being better in terms of efficiency, incorporating the use of recycled materials and so forth. So what's been achieved is, well, effectively that the product quality overall was equal or even better than what has been used at the moment. Production costs were reduced by approximately 74%. So not exactly the value I was quoting before, but very close in that case. And on top of that, the reduction of the tool costs was done by approximately 80%, which adds on top. Cycle time, also not exactly 1 minute, but very close, and including a high amount of recycling material at that point. So what I wanted to demonstrate with that quick example is, of course, the exact values will highly depend on the particular part we're talking about. But I just want to make the point that effectively with such smart new ideas, we can actually get close to those targets that we set out. And we were then benchmarking that across different projects at the end of that project. But we were also focusing on enabling technologies. So here's just one slide from a project which was called MyZFP, where this is the acronym for non-destructive testing, NDT. So this is about ultrasonic inspection in this particular example, which was done with Airbus and BMW, probably also about the first time that a company from aerospace worked together with a company from automotive in that field. That's just, by the way, historical, because in Germany, they were taking completely different routes to NDT. Yet it was quite successful that way that we were able to work on the integration of more automated approaches for, in this case, ultrasonic testing, but also in the exploitation of the use of computed tomography to model the response of ultrasonic signals. So here is some details of the internal structure, which was embedded in a layup. Then we were modeling ultrasonic signals, which was the model that was being used by this robotic system to evaluate the degree of porosity on the inside of the material, which in the meanwhile has been used in series production for the quality control of those parts from Airbus helicopters. So all of those are little success stories for the companies. Starting out with the help of the universities and the research institutions and then ending up in products. Now, sorry, at the same time, we realized that we need to look closer into digitization. So everyone is familiar with the keyword of Industry 4.0, I think. So we also started out to think about what this branch can do for our carbon composite materials. So that's how we laid out the Campus Carbon 4.0. And of course, the key sectors are pretty much unchanged. So we have the same companies in the area. So they didn't change within 5 years. But what did change is our goals. So now we're talking more about digitization of this whole value chain in all kind. We talk about smart production systems already. So this will be the baseline also for the AI production network. And again, we're also having in mind that we need to include the broader public. So we also want to increase the technology enthusiasm for those aspects we're dealing with technologically. So again, here's a quick overview of the project. This is not as highly donated. So this is just 21 million euros, but nevertheless. So it is still ongoing, as you can see. So the last projects are still running. And again, it is dealing with the same areas: production systems, efficiency and sustainability, and design and engineering. So here is just a few projects. And again, I will take the same approach, just present you 2 selected projects to get you an idea. So starting with the project Campus Carbon 4.0 Cosimo, Composites for Sustainable Mobility. So this is a project which at its heart is a production process of a high pressure infusion process of carbon fiber polyamide 6. So this is a very delicate process which can go wrong if processing parameters are not correct. So it was one of the other requirements to integrate sensing systems to monitor what's going on during infusion and polymerization. So you can see a photographic image on the left-hand side. So this is actually still in the research facilities of the German Aerospace Center. So this is not an industrial plant. It is what we operate here on the campus. And effectively, this is just approximately half size of what is planned in the industrial scale. So effectively, the idea would be to produce a bottom part of a car for battery packages, for instance, in one shot, in less than 1 minute. So the loss of value, if that step goes wrong, is incredibly high. So we wanted to do our best to monitor that very closely. So what we fitted alongside is a model-based digital twin of the process. So we're having an online process simulation running, which is fed with the sensor data to be stabilized and to provide you a correct insight of what's going on. This has been analyzed with AI as such, and therefore at the end allows a data-based process adaptation of that whole step. So also I'd like to make the point that we're also using a high amount of recycling material, which is a challenge on top of everything else, because with recycled material in the composite world, at least, we have a huge degree of scatter of the input material grades. So the charges are different. So we always need to adapt our process parameters to the quality of the recycling material. So nevertheless, the process step as we laid out with an active monitoring and control is perfectly suited to take care about such scattering of material properties. So another project that stands as an example for what we're doing here at the moment is the CC4 Fast Move. So this is about CNC machining, as you see on the right-hand side. And in fact, it is about CNC machining of composites as well. But it is not the target of that project. So here we had a classical CNC machine, which is built from metal. Nevertheless, we were aiming for higher movement speeds to increase the CNC machining speeds in general. So we were redesigning that whole machine by replacing heavy parts which are moving. So the portal as well as the Z-axis here. And this was replaced by a hybrid carbon fiber metal solution to make it more lightweight and to increase stiffness, and therefore allow up to 4 times higher movement speed during machining. So nevertheless, when we do that, the construction becomes less conservative. So everyone was quite concerned about potential accidents. So what was incorporated in addition was a structural health monitoring system. So integrated sensing solutions that monitor that the precision of that CNC machine is still kept under all operational circumstances. Yet it is not the only thing. We're also closely looking into the machining of the parts itself. So we were also including sensing systems to monitor the machining process with acoustical and optical sensing systems to ensure the quality of that production as well. So those are now probably 2 isolated examples of research and development projects, yet again, both quite nice success stories already. So let me therefore bring you to the third part now. Oh, sorry, I admit I have to summarize a bit what was achieved within those 10 years in all of those projects. So here's a couple of numbers to get you an idea of what is the outcome of all of those projects together. So if we take the state of the art in 2012, this was when we started with that first cluster. The prices per kilogram for the production of a composite part were about 80 euros per kilogram if we take just the production level of 5,000 parts per year. If we go up into mass volume production of like 50,000, of course, prices go down a little bit, but again, 65 euros per kilogram. If we incorporate a couple of factors like a reduction of the material price due to new materials, if we include technological optimization and combine all of those factors together, this is where we are now at the moment. So we're really in an area which is about half the price at that time. And if we go into the high production volumes, it's really below 20 euros per kilogram, which was the original goal been set by the automotive industry, at least. Of course, in the meantime, they're telling us that they want to get even lower euros per kilogram, but nevertheless, it is approximately, I think, a factor of 4 been achieved if we take that seriously from the low volume production that was taking place at 2012 to the mass production that we have today. And on top of that, we also developed a very strong network. It is really difficult to show the interrelations between the different companies and the research facilities here. So this is just the links between the different projects that I was showing you, categorized into those production systems, design and engineering, and efficiency and sustainability. And this was evaluated during the runtime of those projects. And the darker the lines, the stronger the links are. So I just want to make clear, not every project is related to all the other projects, but there is very obvious links to other projects. Like, for instance, this My Skeleton that I was showing you, this followed up with a second project, the multi-skeleton, and then followed up with an even further project than which has currently been set up. So there is some clear links and a very strong interrelation now with companies and research facilities. Yet we can do better. So in particular for the industry, for the university, there is always this idea that we're focusing on our basic research, and it is very hard to get from that level to the industry. So therefore, we recently get donated a big project, a 10 million euros project, which is called WIR, so Wissenstransferregion Augsburg, standing for Knowledge Transfer Region Augsburg. And in this case, we proposed a showcasing approach for realizing that knowledge transfer. So what's that about? We first defined areas where we do have to offer high quality research. This would be the baseline, of course, to provide something to offer to the industrial partners. Then we defined and developed showcase ideas, which we can also freely expose to the public. Reasons for that, I will get to that later on. And we also set up a laboratory, not in our closed facilities, but really easily accessible to the public to allow that exposition. On top of that, we then started to experiment with new formats, how to communicate such high-tech developments to a broader public, including industrial, of course. And we also identified suitable means besides regular projects to collaborate with industry. So I was showing you those classical research and development efforts just before, but it's not the only way to collaborate with industrial partners, of course. So that is our innovation lab. It is just a collection of different fields where we do have a strong competence, many of which might be familiar to you already. So it is what the AI production network was inspired from. So here is again the robotic systems for automation. We're also having the integration and linkage of different systems already. So here is the CNC machine that I was just presenting from the project before. And all of that nice setting was integrated in that Technology Center Augsburg, a place where even through the windows, the public can just walk by and have a look at what we're doing. But it's also easily accessible, of course, outside the Corona times to be visited and just taking a look and getting in connection with us. So here is a couple of impressions of what we're doing there. So on the upper left, there is the head of that project, Professor Reif, and also the person that initiated pretty much of what I'm talking about, Professor Horn. And on what we were doing in the beginning, of course, we didn't have all of that set up in the first minute. So we were offering virtual tours with the use of augmented reality to demonstrate from the first minute what we're planning. And while everything was growing up, we're also had a mix of existing components and the use of augmented reality to add all of the missing parts to get everyone an impression of what we're planning. Of course, we're exploiting the use of social media, as you can see in the center, and not just the usual and regular schemes, but also with a certain amount of experimentalism. And we're also offering live video recordings from our technological fields. So this was driven a lot by the overall global pandemic, but nevertheless is an interesting new format to collaborate and interact with the broader public. And on top of that, of course, we're also trying to do excellent research with those facilities, so to also have something to offer at the end. So therefore, let me bring you and show you the next steps. What we're planning, getting back now to this AI production network, is a common research infrastructure, not just for the University of Augsburg, but very closely together with the Fraunhofer Institute and the German Aerospace Center. So we want to operate that facility together. We're having an AI committee, been defined as a good mix of all of the partners from the region, so from the government, but also from the chambers, and also from representatives of different fields of industrial enterprises like the cluster mechatronics, but also from the field of composites and the engineering. And we also want to establish tight links with our University of Applied Science, which is also located in Augsburg. So we have a good history of collaboration altogether with them as well. And with all of that, we want to leverage what we are planning. We want to have the funded projects been initiated. We want to have that training and education that we were mentioning in the beginning, and been able to deliver that to the industrial companies to increase their capabilities in the field of artificial intelligence and production technology. As a little roadmap, again, we're just initiating all of that AI production network. So we're already working on fast-track research and development projects, which are initiated together with the companies. Yet, as a follow-up, we will then also turn into those regular collaborative research projects, and hopefully, already looking far into the future, we'll have follow-up projects on all of that. Of course, we're also planning a massive invest in personnel and also into our research facility. So we want to do a quick start right now, and then hopefully expand that after mid of 2022. And last but not least, we have to grow up our technology campus and find a facility to host that infrastructure. The planning is already ongoing, and hopefully we can build that up very quickly within this year before we move into a fully operative phase then by mid of next year. So with all of that, maybe 3 key lessons that I wanted to pass over to you that we've learned throughout the years in how we laid out that collaboration with industry. So first of all, we should not isolate everything from the technological developments. So they should fit alongside with industrial requirements and societal needs. If we have such a strong network, we have key partners and key topics. If we have that strong focus, we can initiate a close collaboration altogether. And as a big thank to our government in Bavaria, but also to the federal government of Germany, we had the lucky chance to get attractive governmental funding to enable us to set all of that and to realize all of that. And if we do that more often, I would propose that researchers may consider more often to also turn into those applied research topics. So therefore, please feel free to get into contact with us if you want to exchange on more details. And I'm looking forward to any questions you might have on what we're planning. So thank you very much for your attention, and looking forward to your questions.
Thank you very much for your presentation, Professor Dr. Malte Peter and Professor Dr. Marcus Sause. And any questions? We have to check the...ちょっとわかん、
Okay, thank you for your presentation. Basically, I can see 2 questions. The first one is at the early slide, you talked about human-centered AI production, and that seems to be a quite demanding task. And could you tell us the concept of human-centered AI production or operation? That's the first question. And second question, you mentioned several times that public visibility is important. So is that mainly because of the marketing purposes, or you have a kind of aiming at the public awareness? So these are two questions.
Okay, I'm going to take the first one, as was on my slide. So, well, human-centered production, I read the question so that the idea was it could be an opposing concept. Effectively, we want to avoid that this turns into reality, so it shouldn't be opposing. The idea would be like if we run into automation, what will happen to the workers in the companies? They're simply getting replaced by a robot. And what will happen in their mindset is, well, I got replaced by a robot, so I got unemployed. So all of that technological development is a big mistake. So the idea would be, rather than doing that, being responsible and thinking on how we can fit AI developments and automation developments alongside with the human capabilities that we all have. So we still have a huge amount of creativity, and also we're still better in many ways than AI at the moment. So therefore, we want to bring in AI production technologies at that point where we can really release the workers from burdens that they don't want to have. But they should still be the persons that oversee the production processes and therefore work together with an AI assistance system rather than overridden by an AI assistance system. So that's the big difference in that case.
Okay, thank you. Although quite many people are still afraid of being out of a job because of development of AI, but as you pointed out, we are hoping that the factors can work together in the future. So the second question is public visibility. You just mentioned that your operation has to be visible for public. I believe that was the general public. So you're keen on doing it because you want to raise the awareness of general public, or you have a marketing purposes?
Yeah, it's dealing with our latest project that is still ongoing, where we did choose that showcasing approach. It is actually both parts, to be honest. So of course we want to showcase what we want to offer, what we have to offer as a university. So therefore it is a marketing idea indeed. But it is also owed to the fact to decrease skepticism in the broader public. So again, if we start to work behind closed windows, everyone can speculate what we're actually doing all day long, and everyone can get skeptic about why to spend many millions for doing whatever abstract research. So therefore, if we clearly show what we're doing, that's a very big plus to the broader public, because then they can familiarize themselves with those technological developments and can really imagine where all of this money ends up.
Okay, thank you. We have many questions coming in. The first one: how will participating companies of each project be decided? You mentioned like BMW or some other aerospace companies. How these companies are decided?
Well, effectively, it depends on the type of project we're talking about. I was demonstrating you many different projects from the past. So actually, in the past, it was much more difficult because we didn't have so many links with different companies. So we didn't exactly know what they are interested in and what they're planning next. In the meantime, we have, well, first of all, professionally established structures at the university, as well as in the different clusters that were developed the last 10 years. So there are persons that know very well what the companies are planning and also what they would be interested in. So if either a company does have an idea where to go next, they will approach those persons and get into contact with them so that they then can all put together a network of companies and research and development facilities to get the project running.
Okay, thank you. The purpose of this question is that if Japanese companies, any of Japanese companies want to join your project, how can they join your project? Do you have any procedures or criteria? I think that these Japanese companies are interested in joining your project.
Well, I can just talk for the operational part, but I think maybe it's better.
Professor Peter.
Well, I think it's really about approaching us and talking about what should be done. As was explained, there's basically it depends. Because there's certain funding for certain projects, and of course this funding is given by the state of Bavaria, so there are certain criteria. But for these kind of funded projects, but for getting in contact with us and for basically being interested in research, we're always open to discuss, and please just approach us, I'd say.
Okay, thank you. I think the related question next, do you have currently any Japanese companies working with or for this project? Or do you have any Japanese engineer or researchers involved in this project?
Well, the AI production network, as mentioned, is still very new. So we're not even having fully incorporated all the companies over here, or at least we didn't officially establish that in a formal sense. So therefore, the answer for the AI production network is no. So there's no Japanese companies either. Yet, of course, we're looking forward to integrate not just German companies, although they, of course, also having international networks to work together with. But just for other reasons, we're also establishing links, of course, to other areas in the world, like also South Korea for the field of composites. So I guess there would be open doors if there is an interest to collaborate more closely on that.
I think we might be able to provide your the names or contact details or something like that to the participants, so that these people can access to you. Or I can ask Kinga-san to help us to do so. I think these companies are interested in your projects, I suppose. Okay.
So any more questions? No more questions? Okay, so, well, I hope you enjoyed our webinar. If you have any other question on this webinar, please send us an email. We will get back to you. Could you, Yamamoto-san, could you give me the...
Right.
Yeah, please.
Okay.
So here is the address. So, I mean, any other questions? I mean, if you have one, please send us this one. Okay, Mr. Sasaki, would you like to state?
Yes, thank you very much, Professor Peterson and Professor Sause for the presentation. And thank you very much, Dr. Gertinga-san, for your great cooperation for this joint project. And thank you very much, everyone. The industrial tie-up between Bavaria and Saitama has been more than 10 years. Now we have a lot of joint projects between Bavaria companies and Saitama companies ongoing. So I hope this industrial tie-up will continue for next 10 years or 20 years to grow both companies. So thank you very much.
thank you again for your time. This is the final one. So I hope you enjoyed our webinar. Thank you very much.
Yeah, thank you very much.
Thank you very much.
Thank you very much.
Thank you very much.
Thank you.
Thank you very much. Thank you very much.
Have a good evening.
Have a nice weekend. Thank you very much.
Yes.
Yes, and Saitama-san and Mutsuo-san, thank you very much.
Thank you, and bye-bye.
Thank you. Bye-bye.
Go.
Gertingo-san, our fiscal year is the end will end in the March, but we also have this kind of the seminar in the next fiscal year. So I want to ask for your help in the next fiscal year.
Yes, definitely. I think this is we should continue.
Yeah.
And review the previous seminars and get ideas for the upcoming ones. Yeah.
Yes.
Certainly, we have many more topics that we can cover. I'm pretty sure.
Oh, yeah. Yeah. Thank you very much.
Okay. So now I'm sorry I have to leave here because I have another call.
Thank you very much.
And yeah, thanks again.
Yes,
and,
thank you very much.
Good luck and have a nice weekend then.
Oh, yes, thank you very much. Have a nice weekend. Thank you. Thank you.
Thank you.